frequency of oscillation in megahertz for a 101 stage ring oscillator built from inverters which have an average gate delay of 36 picoseconds. Now your question might be a little bit different. These variables might be a little bit different. We're going to enter 0 if the circuit won't oscillate, and we'll talk about that as well. So the equation that I have, and I've pulled this from a previous video, but it's in the description, we have our frequency equal to 1 over 2n TP. That's just a general equation that we're going to use. I plugged in my values right here. We want it in megahertz, so I'm multiplying it by 1 mega over 10 to the power of 6. That's how we would convert it to megahertz, and we get 137.5 for this. And so our answer is going to be 137.5. So that is kind of like step 2. All of this is like step 2. And the reason why I say this is because the first thing, step 1, should be looking at the average gate delay of 36 picoseconds. So the reason why I say this is kind of like a step 1 is because this determines the average gate delay. I found it determines, I'm not 100% sure, but average gate delay of 36 picoseconds determines if our circuit oscillates or if our circuit is 0, if it won't oscillate. Now, I couldn't find too much about this, but for values of like 36 and 27 picoseconds, it will oscillate. And for lower values like 12 or 13, I don't know the exact magic number, but 12 and 13, I found that it will not oscillate. So I believe it has to do with the average gate delay. If it's too small, it won't oscillate. And if it's large, it will oscillate. Haven't found the exact number. That'd be very helpful. But that's how I looked at this problem.